All right, so basically what we need to do is make sure that we can recognize functions immediately and figure out what family that function belongs to. So when we talk about families of functions, we mean functions that may look different from each other, but they're the same type of function and they share some basic overall characteristics. So for example, we have lines here. And lines in general have two characteristics. They've got a slope and they've got a location. And the best way we usually describe the location is by talking about its y-intercept. So if you have the slope and the y-intercept, you can define any line, right, and figure out what that is. So the slope of a line is just the steepness. So we can see how I'm changing the steepness of this line. I'm really changing the slope of the line. Right now, an increasing function has a positive slope. A decreasing function has a negative slope, and right here, a horizontal line has a slope of 0. Okay, so those are definitely things you want to be able to recognize right away. And it makes sense. You can think about these things in terms of a bank account, right? If your bank account looked like this, that would be good. If your bank account looked like this, that's bad, right? So and if you had a bank account that wasn't accruing interest and you weren't spending or putting money in there, it's going to look like this. It's going to look like, we call this a constant function because the value is just constant. It's not changing, and that just ends up being a horizontal line. Okay. The next we have is polynomials, and polynomials can take on all sorts of different shapes depending on the particular polynomial. So what happens is as you increase the degree of a polynomial, it can become more complex. So like here we have a second degree polynomial. That's going to have the shape of a parabola, but as we increase things, now we have the shape of a cubic. Right? So it can have more turns. See how it's a little bit more complex? It has more turning points. It can have more maxes and mins. There's more interesting behavior that can occur. So an 8th degree polynomial has the potential to be a lot more complicated than, say, a 2nd or 3rd degree polynomial. We also want to keep in mind that polynomials are smooth, continuous curves. And in certain circumstances, that's very helpful to us. That can be very beneficial, especially when you get into calculus, something like that. Polynomials they can be nice to deal with. The well-behaved nature of polynomials can be very helpful. All right, then we have rational functions. And rational functions can come in many different shapes and sizes as well. Here's one we can kind of see how they're changing a little bit, right? Here's some versions. These are rational functions as well, so they could take on different shapes, all these things. And we can come up with fairly simple rational functions as well. This is a rational function also. Okay, so we've got that. And then we've got exponential functions. So we've got exponential functions, right? Exponential functions lead into logarithmic functions because logarithmic functions are the inverse of our exponential functions. So you get things that look like that, right? And again, we want to understand the domain and range. The exponential function is a very fast growing function. It increases very quickly. So the inverse of that function, the logarithmic function, is a very slow growing function. Okay, so if we zoom out, we can see it actually looks like it's got maybe a horizontal asymptote there, but it doesn't. That function keeps increasing and it'll keep going up. It just takes a really, really long time for it to increase. Okay, but it is very slow growing. And then one distinct feature of these functions, we have the absolute value function. So it's the only one we've seen so far that has a sharp corner in it. Those sharp corners can cause a little bit of difficulty when you get into calculus and stuff like that. But here, if you see this V shape, this distinct V shape is usually a dead giveaway that you're dealing with a absolute value function. So we want to be familiar with these. You might see these in different forms when we talk about transformations, and we can take these and transform them into more complicated versions, but you want to be able to recognize, oh, that kind of has a V shape. That looks like it's some kind of absolute value function, and then you know what tools to apply to that function.